everyone. Today we are going to discuss about AND OR gate realizing with the help of diodes. So for that you have to remember about AND OR gates, its Boolean expression and its truth table. So in this lecture we are going to use diodes to make AND OR gates. So let us start with its basic. Digital circuits logic uses the fact that diodes conduct only in one direction. We always discussed about the diode that it only flows in one direction. We can say forward direction, forward bias. So similarly here it behaves like switches. As we discussed earlier that if it is in forward bias, that means it is look like closed switch. If it is in reverse bias, that means it is open switch. So here diode work like open and closed switch. We will have two logic levels. One 0 voltage, that means it is in analog term 0 voltage, that means low, and 5 voltage, that means high. So in digital we can say it is logic 0 and logic 1. So here we are going to discuss about its input 0 voltage and 5 voltage in analog form, or we can say 0 or 1 in digital form. So let us start with its AND gate. So in first chapter we have discussed about diodes, that we can use diode in only one direction like forward bias, whereas it is in reverse bias it becomes open circuit. So that funda we are going to use in this realization. So here AND gate, that means here we can see this is the symbol of AND gate. Now its Boolean expression is multiplication of two inputs. So if A into B is equal to your output, that means whatever you will provide here at the input side, you will get multiplied of that input. That means if your both inputs values are 1, then you will get 1 at the output side. So here we can see this is the animation of your input to output. This is the relationship between the input and output. So here we can see this is the two input AND gate and its truth table. So here we can see if I entered 0 0, I will get 0. If I entered 0 1, I will get 0. 1 0 0. But both the inputs are 1, then I will get 1. So with the help of diode, I have to design AND gate. So let us design AND gate using diode. So assume the input voltages are either 0 volt, low, or we can say logic 0, or 5 volt, high, that means logic 1. Here we can see this is the circuit diagram of AND gate by using diodes. So there are two diodes positioned in this circuit diagram. So above we can see here there is a V, or we can say it is plus VCC, right? So your power supply is V. Here we can see A and B. This A and B indicates you will provide input at this A and B side. That means we have seen in truth table 0 0 0 1 1 0 1 1 possibilities of input values which we are going to enter here A and B side. Then we will get output at the output side. So here remember this thing, if I provide here 0 and below in B 0, both are 0. Now current always flowing from higher to lower side. So here we can see plus V or V, there is a 5 voltage. So current flowing from this direction, V to A and B. That means it becomes in forward bias. And if it is in forward bias, that means here we can see diode D1 and D2, it becomes closed switch. if it becomes closed switch, that means your output will be 0. There is no flow of current at the output side, because here we can see there is no resistance, so current always flowing from B to A and B side. So in this, if we applied A is equal to 0, B is equal to 0, at this time your output will be 0. Now next, if you applied A is equal to 0 but B is equal to 1, right? So here similarly current flowing from this direction, because A is equal to 0, still there is a closed switch, so always current flowing from low resistance, closed switch, so current flowing from B to A side, so that is also your output will be 0. Now next 1 0, similarly here there is a 1 closed switch, so that's why your output will be 0 again. And finally, if you enter A is equal to 1, B is equal to 1, that means higher, so current does not flow B to A and B side, because it becomes open circuited. Here if diode D1 and D2 becomes open circuited, then and then you will get your output value. That means if you applied A is equal to 1 and B is equal to 1, then and then your output will be 1 at your B output side. So this is the basic theory of AND gate using diode. So here we can see practical circuit. In this circuit diagram we can see here, if there is a 0, then here we can see D3. D3 is your LED. It is not lighting because current flowing from A to B side. That's why there is no flow of current at the LED side. So if you applied here we can see 1 and 1, then and then your light is emitted. Here we can see it is emitted. So this is the practical circuit we are using for AND gate with the help of diodes. AND gate using diodes. Here we can see in this circuit diagram, this is the, we can say, equivalent circuit of AND gate using diode. In A we can see there is a 1 1. Both the inputs are 1 1. A is equal to 1, B is equal to 1. That means it becomes open circuited. So current does not flow A to B side. That's why your output will be 1. That's why here we can see Y is equal to 1. Now in B, here we can see in B there is a 1 closed loop, because there is a is equal to 0 and B is equal to 1. So A is equal to 0, that means current flowing from B to A side. That's why it becomes closed switch, and that's why here we can see Y is equal to 0 voltage. So this is the practical explanation of AND gate by using diodes. So with the help of diode we can realize AND gate. So here we can see in C, this is the truth table of AND gate. Now similarly here, this is the operation of AND gate using diodes. That means if A and B are low or any one input is low, both the diode will be on. That means in forward bias. So this is the explanation of AND gate using diode. Similarly in case number 2, we can divide case number 1 and case number 2. Case number 1, both the inputs are low or any one input is low. Now here in case number 2, both the inputs are high. That means your last case, last possibility, when A is equal to 1 and B is equal to 1. And at this time, diodes work in reverse bias. So it will be off. Here we can see both cases for 4 possibilities. Similarly here we can see this is the OR gate. here OR gate, its Boolean expression is like, it is y is equal to, y stands for output of OR gate and A and B is the input. So y is equal to A plus B. So this is the Boolean expression of OR gate. That means if you enter 0 0, your output will be 0. If you enter 0 1, then your output will be 1. If you enter 1 0, then you will get 1 as well. And finally, if you enter 1 1, both the inputs are 1, or we can say high, then and then y is equal to 1. So this is the Boolean expression along with its truth table. Here we can see this is the symbol with truth table of OR gate. So we have to realize OR gate by using diodes. So there is a little bit change of direction. Here we can see this is the circuit diagram of diode. A, B, here its direction is input to output side. So here this is the direction of diode is changed compared to the AND gate. Now similarly here we are going to apply 0 0, then you will get 0, then after we will apply 0 1, 1 0 and 1 1. So we divide these 4 possibilities in 2 cases. Here like we can see both X and Y are low. That means your case number 1, your possibility number 1. Then your diodes are off. We can say it works in reverse bias. So diode will be open, there is no flow of current, then that means your output will be 0 volt. Now other possibilities, that means 0 1, 1 0 and 1 1, we consider it in case number 2. That means your any one input is high or both inputs are high. That means inputs are at logic 1. We can say 5 volts in analog term. So current will flow to the one or both diodes. That means current passes through the resistor and causes appearance of the voltage across its terminals. Thereby we will get logic 1 on the output side. So these are the 3 various possibilities for case number 2 here we can see. So that's all for today's lecture. If you have any query related to this explanation, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.